This is IBM Museum. In this video, and don't kid me about not changing my clothes from the prior video, I did change my hat, but I wanted to go over the SIT, System Information Tool, on a PS2 Model 33E that I had pulled out. And look at this little beauty. And PCMCIA slots in there. Little 3.5-inch diskette drive that's in the other position. And this thing is just chock full of nice little features. That's the PCMCIA ports on the back here. But beautiful system. But I thought, hey, why don't I go through and run the, not IBM's version of SIT, but my version that I did for DOS, VisualBasic for DOS, years and years ago. And then I have a Windows version I called WinSIT that I want to run through. And I found that on the development machine that I used, actually a Model 9556 model. So it's a Model 56, and you know that has the, or I can tell you now that it's the CPU encoding of E as in Edward. So you know that's a 46 SLC3 now, 75 megahertz. But I use that machine as a development system and started looking through what I'd written years ago, and even figured out that I had a copyright year in there, a single copyright year of 2002. So I'm not even able to invert those last two digits of that copyright to start working on that program again. I just tacked on the 2021 after the 2002, starting to work through that again. So I'm going to run through the DOS version of that that I just have. And I've actually changed a little bit of the coding around, as we'll go through and see. I have just a batch file that I run this from for the VisualBasic program, and then I've got that development environment that I can go in, and I've been slowly trying to, I haven't changed any code yet, but looking to use that to start adding some code in there. And you can see we're all booted here. We have the, since the system has the planar SCSI, it loads the SCSI driver that IBM had for the CD-ROM. The unit has the CD-ROM. And then I'm also loading the mouse driver and other things here. So I'll have access to all that. Okay, and I think it even ran the mouse.com again. And I thought this would actually run the executable straight off the bat. Maybe I have to go through, but this is kind of what I had going through in the same sort of order as what IBM had their System Information Tool, down here in this corner that I have with the red mine marked over it. And when I look through this, I don't have all of these other buttons. I don't have them giving any screen information. I didn't populate that enough, except for this model and processor information. And let me find out if I've got to, and I should be able to pull this, and you can see the mouse cursor in this case in VisualBasic for DOS is that block pointer. Yeah, I can drag that far enough. And that's just a close button that's off screen behind me, my webcam image. And so I have, in this case, my version of SIT the system information tool, as identified at the top here, as a little bit more detail. And I go through and I do some of the things in a little bit different order. I'm kind of choosing this as the current order. I went through and I like kind of the layout now of how I do the planar ID at the top rather than listing at the bottom like IBM does, and giving a little bit more information. I haven't decided yet. I'm getting that machine name from the planar ID, and I may actually cut that down or do some code to reduce that to actually showing it as it would appear on the badge, and determining what CPU is in there. I don't got any code for running timing to check the clock speed, but I know a lot of time from planar ID and finding a particular CPU that I can identify it at a particular speed. And I don't want to hard code values in there like IBM has. I want the values to be real and for the system to gain those in real time. But so I might make some changes with code rather than just do a generic by the planar ID, since both of the planars with both of these CPUs on the planar identify themselves this way. And the only possibility is, I could identify a planar when it actually has a CPU effectively on the daughter card for that system, like that 46 SLC2 planar with the 46 SLC3 daughter card. They're function equivalent machines, although they're slightly different planars, and it ends up being the same CPU clocked at the same speed. But I do get a little bit more information here, and I'm rather pleased to see with this. I mean, it's got BIOS revision 4, and IBM doing that development up in mid-year of 1993, which is, just about the final portion for the PS2 series. It's when IBM started moving on to other things. And then on an earlier area I had where the working with the raw value of the CPU ID, and I had a CPU stepping of that 3.9. But when IBM encoded this too, and this is another indication of what processor, IBM did the leading A and a 4 to mean that it's a 46 class, and that third digit is actually a multiplier. So they have A301 is a 386 SLC CPU that's not clock multiplied. It has a 0 in there, and it's like the first stepping that IBM had for that. There's the 46 SLC2, and I know 2 stepping versions of that, but that starts out with the number 4 for meaning the 46 class, and then it's got a 2 for that third digit, meaning it's clock multiplied or clock doubled internally, and then that last digit being the stepping version. I think they have a 1 and a 2 in the case of the 46 SLC2. And then this is the only variant I found, or the only stepping I found of the SLC3. And that's where it's the A, and then for IBM, 4 for the family, and a 3 for the clock tripled inside internally. And in this case, I'm going through and I'm choosing a more generic that I don't really know the stepping version. I've only found one version, so I can't really compare of what that is. And some of this is hard-coded here for the internal cache size. And I think I can check by the function of whether that, to tell whether the L1 cache is enabled or disabled by this enable disable processor function supported. So I'm doing that and adding that additionally to my information ahead of what IBM actually does. And that's my primary intent with these, like I had for that SCSI level. And I'll demonstrate that later on and run that on the Model 56 as well. In fact, as we step back to DOS, I can do that real quick and kind of show you the results. And that's the reason I go through and modify these programs and utilities to add more features and to expand the model coverage for them as well. And then it's just listed in coprocessor. And this unit does not have a coprocessor, as we'll see in the Windows version. I've gone through and done a little bit more of that. So we're just going to go through and close. And I don't know if the close button that's hidden behind me on this screen even works, but I'll go through. And this VisualBasic for DOS, it's nice coming up with a DOS full screen application. I mean, it's not a GUI, it's not graphical based, but it is text, characters, and very easy to have. And and I didn't change it here. I changed it on the Windows version. I'll have to change it here as well. And I reveal a little bit. Maybe I should have slid that over a little bit more to to conceal a little bit more about me, but that's fine. People are gonna learn enough of that information as it is about me anyway. And those windows do very similar functions as what you would see in Windows 3.1 programs from the menu system and even later. But and then file, and then so I had the ability to go through and plan the ability to save kind of a fingerprint of the system to show what it is, or even open a file of a previous system. I could go through and have even submissions go through to for people to give that file of what they had for their system. And I would go through and time and date stamp it as well, and have it to where the person could go through and mark up some information. And these dialog boxes are built into VisualBasic for DOS. So it's real easy going through on the form, and them having hot keys, that Alt-S or Alt-O or Alt-X in this case. And then the ability also to print those kind of a listing for the system as well. So that's my expansion that I had planned for this, and I'll go through and populate this and kind of try and unify the code otherwise as I go through on that. I thought it told it. Oh, okay. And typically it tells me, it tells you press any key. Yeah, press any key to continue. I didn't see that at the bottom, and that takes you back to the VisualBasic environment. And this is all the, just a brief showing of the code. I can probably go over this in a little bit more detail when I come a little bit more to finishing it. But for people that use the VisualBasic for Windows, and there's only the one version of VisualBasic for DOS, and then Microsoft abandoned it. And they went through several versions of VisualBasic for the Windows environment. They started with version 2 was the Windows product, and I had that. That's where I started into VisualBasic, and they went up to like VisualBasic 7, and then they started calling it weird things like VisualBasic.net, and incorporate that into some of the Office products, the scripting and things like that you could do in there. But I've kept those old development environments around. And that's just kind of a brief look at some of that stuff. Back out the DOS prompt. I have it in the, in fact, I know I have it because I tried it. I have this in the root directory. And so that's the IBM version. And the response from their program of no IBM PS2 microchannel SCSI adapters were found, even though this has SCSI on the planar. And that's why I wanted to modify that when I first saw it and said, hey, there's mods with IBM SCSI. How come I can't modify that program or expand that program a little bit better so it covers all the models that have it and gives a little bit more detail than IBM did initially? But let's go through Let's get Windows running. It's Windows 3.1 as you see here. And I don't have this machine networked or anything like that. I'm not running Windows for Workgroup. And as you can see down at the bottom, I have all those VisualBasic versions. And then VisualBasic 4 was the first version that had that 16-bit version and the 32-bit version all in the same package that you could install as appropriate for developing. And I actually do have a link to the IBM version here, and this they've got an embedded icon within that executable program for their program of that. That's the icon that they've created. And since I linked that under the Windows 3.1 interface to be able to run that, that's the icon it gave me there. But here, and I need to separate it and develop it probably a little bit more. I'm just basically starting up the VisualBasic for Windows environment. And as you can see, this is the 46 SLC3 CPU, 75 megahertz, and that 16 megabyte of memory, and it handles Windows 3.1 very well. I mean, it's very responsive and everything else for that nice, fast SCSI drive. I was showing the icon works. And so here I had that WinSIT 16, and I don't know if I even did a 32-bit version of it. When you start getting into other Windows platforms, of course, especially Windows NT, with that hardware abstraction layer, it's going to prevent you from hitting the ports like you typically see. And I don't see... Did that minimize? Yeah, okay. So I don't know if I accidentally clicked off the side and minimized that away, but that's the this is the development environment, as you can see, for adding the various things, labels, checkbox, combo box, and basically you just drag them into the window. And it was a very novel, I mean, not the operating system like Novell Network, novel. It was a very novel way at the time of going through and being able to quickly develop Windows programs. And over here on the right, I mean, I have all my code and form listings to go through. As I say in here, I did go through and change that copyright date. I don't know. I didn't have any file menus. I don't know how I had access to the about window in this case. But let's drag just a little bit left. And as you can see, the same kind of layout is what I'm intending here in the Windows program. And a lot of time I choose to do that, to mimic what the program replaces, like it's a new version, and then going in there and determining where I'm going to add some of the details of it, expand that information. So this system doesn't actually have any microchannel adapters in it. So it's going to list those 3 slots. And I think on this system, I may be going in there, and I'm saying number of microchannel slots, but that SCSI interface on the planar, possibly the XGA2 interface on the planar, those are treated effectively like slots as well. And I can go through and I can limit down whether those are identified here or not. And probably in code, I'll go in there and identify if it's a planar resource and I'm able to determine that on the system. I'm going to go through and split that off and have that identified differently than necessarily as an adapter. But just kind of handy to, for as I go through and do development. Some of these buttons are dead. Disk information, I know the keyboard, it's kind of, I'm going in there and developing. I've just had to do some text in here that we see. And this is real-time, queries to the system. I have not hard-coded these values. It's actually checking for the keyboard functionality call. It's going through and getting that same interrupt call of the int 15 hex function C0 hex as far as the what's called the get configuration. And that's where it gets all the BIOS date and version. Memory information, it looks like it brings up a window, but doesn't do anything. And then here I have that miscellaneous technical information again. And again, this is all real time of going through and presenting the same information that IBM does, but just going through and adding a little bit more. I can't remember in the IBM version of SIT on whether they go through and actually give the value where that extended BIOS data area is in this case, and you can even get the size of that that information as well. System has a microchannel bus. DMA supports 24-bit address space, and of course this is a 24-bit address system. 16 megabyte of RAM maximum. Returns POS data call supported. Return memory map call supported. Information panel not installed. Data streaming unsupported. SCSI subsystem present on the system. And there I could go through for the other information like the disk information. I could go through and make my version, of the SCSI level be reported with this. And oftentimes, of course, in Windows code, you get banging on the ports as well. As I say, Windows NT tends to prevent that. And it can be, in Windows NT can be run on those higher level PS2s. I've got it installed on several of my PS2 servers. But, poking at that stuff too can cause the system to crash, and you want to be very careful with a program that goes through and hits on the hardware directly, as it has to determine some of the information. And this is an IML system. Makes it really nice for those configuration changes. And I'll probably end up having to swap out the battery. I've seen where I run the system and it is fine, and then later on it complains that it's lost the configuration. So I'll probably have to change that 2032 battery in there at some point. And then SCSI support in the IML image. Nothing for operating system information, even though from the Windows standpoint, that's very easy to get that version information. And of course, and Windows 3.1, that's still a user interface. It's not an operating system. It's a graphical user interface on top of DOS. Requires DOS to run. Model and processor information. And this is pretty much the same sort of thing as I did on the DOS version side of going through and identifying a lot more of this detail. The coprocessor, math coprocessor, is not present on planar or CPU because in the case like a 46DX CPU or the Pentium, they have that integrated floating point processor. I give the raw CPU ID data there. And here in the Windows program, like I say, I've identified that as the 46 SLC3 step 9 hex. And I'm not so sure if I'm going to keep that identifying the stepping that way. And some of the CPUs, like the the 386DX, 386SX, the Intel 46DX and SX and DX2s. I've identified a lot of their stepping levels, even though Intel was a little bit more tighter-lipped with the 46 level. They haven't had a lot of information come out from that, and even later CPUs have a little bit more information documented out there. That was when they were kind of fighting for, not being the only CPU company. Again, starting to get competition from AMD and Cyrix and even IBM at that point for their 46 line of CPUs. And I go through for this, in addition to the BIOS revision, I provide that date, but even give the day of the week and write it out in English as far as what day that was, not just those digits, 2-digit signifying the year and split by slashes. And then again, enable, disable processor functions, call supported, going through and adding a little bit of more information that you would have on that miscellaneous data as well, but adding it to this area. And I haven't gone through and added areas in here. And as I say, still, my intent is to provide that information, not hard code it, but have the system checked. And in the memory regard, when you run a program under Windows, that gets complicated because Windows can, make that memory the way it wants or run things in particular ways, that it's sometimes a little bit harder for a program to get that detail. And that's trying to uncomplicate it for the programs that run on it and the programmers to write programs for Windows, but it masks a little bit of that information. I did even have, with the graphical environment, add this view button that's grayed out. And I was even thinking, hey, I could have a diagram or a picture of the planar show. Somebody could actually have a lot of more information based on what my program version determined about it to see, what it looked like inside without even necessarily opening up the case. And, the other thing I like, it's easy to write utilities and programs for the PS2s because they're not there's a lot of utilities and everything else. It helps in functionality and helps with running a utility that shows what goes on behind the scenes, but they're not a moving target anymore. There's not any new PS2 coming out that I have to, that I am not necessarily aware of. I'm aware of all the model ranges, submodel ranges, and everything else over the years. And so, I can, when I give these indications like the planar ID, I'm certain of what planar that actually means it is. And, starting to show those on video in this case. I think the rest of this information is pretty dead. When I go through for the parallel and serial port information, you have to remember, IBM just identifies the number of serial or parallel ports on the system. And I'm going to go further, and besides the quantity of the actual ports, giving things like IO addresses, going through and telling the capabilities of the UARTs or what mode the parallel port could even be in, because that information is extracted. And the video information, I can expand that quite a bit more, just based on some of the function calls and separating all those video things. And on this system, it's the XGA2 video system, and there's ways to go through and inquire. And I even had to pull out a CRT. Put the flat panel screen behind me off to the side and pull out a real CRT for that XGA2 to be a little bit more happier with the monitor identifier frequencies and things like that as well. But that's where I am in the development of these utilities, and So I'm starting to work on them. It looks like after, starting that 2002 period and going through to look this stuff over, starting with now with 2021. So all those number of years of that 19 years later of starting to pull this up again. But that's what I have for my side of SIT. As I say, probably when the next video's up, there's a lot of content that's really fighting for time. But I'm probably going to have that system information tool on that nice little 9533E. Then after I run through just probably a video on running the system information tool on it, of then going through and showing a little bit of the view and the inside and how unique of system that is. And you're not going to find, for instance, a mechanical fan inside to cool the system. It's doesn't have any of those fans. It's treated as being that energy efficient, low power design that doesn't need the cooling. So it's a little quiet system. IBM even had, particular LED, LCD monitors and things like that at the time for it, that were paired with it. And it was a little pricey little option at the time. But I've got a few of those systems and, interested to show them off a little bit on what they have inside and the expansion and other things in that limited case size. So if you like this sort of content, click on that like button. Please subscribe to my channel. Pass the word around. Pass it around to you. If you have any friends that are interested in this stuff, to get them subscribing as well. I'm looking to really just get the subscriber base up here. We've got to get the numbers in, and so I can, provide all that good information out there to more people. And but that's all I have for now. This is IBM Museum. Thank you.